Hi everyone, welcome to Education Hub Zone. So today we are going to discuss about general chemistry. The topic is chemical bond and molecular structure. Before getting started, please don't forget to like, share and subscribe on my YouTube channel for more upcoming videos. Okay, let's get started. Chemical bond. The attractive force which holds together the constituent particles, atoms, ions or molecules in a chemical species is known as chemical bond. Why do atoms combine? In 1916, Cossels and Lewis gave explanations. Tendency to acquire noble gas configuration or octet rule. Atoms of noble gas don't combine with other elements, therefore they have stable configuration. Example, neon, 1s2, 2s2, 3p6. All noble gases except helium have a valence shell configuration of ns2 and p6. This configuration corresponds to maximum stability. Therefore, the atoms of noble gas can neither lose nor gain electrons. Their combining capacity or valency is zero. All other atoms have less than 8 electrons in their outermost shell. Hence don't have stable configuration. Therefore, they have to combine with each other or with other atoms to achieve stable noble gas configuration. Tendency to acquire minimum energy and stability. Atoms combine to form chemical bonds to acquire a state of minimum energy. Isolated atoms have higher potentials, tends to combine to form molecules with lower potential energy. If there is no fall in potential energy of the system, no bonding is possible. Lewis symbols. Not all electrons in an atom involved in the process of combination. Only the outermost shell electrons are taking part in chemical combinations. They are called valence shell electrons. Valence electrons are represented by dots or crosses placed around the symbol. Example of elements of period 2. Significances of Lewis symbols. Number 1. Indicates the number of electrons in the outermost shell. Number 2. It helps us to predict the valency of the element. For lithium, beryllium, boron, and carbon, valencies are 1, 2, 3, and 4 respectively. For nitrogen, oxygen, fluorine, and neon, valency equals to 8 minus group number. Octet rule and modes of chemical combination. Atoms combine either by transfer of valency electrons from one atom to another, gaining or losing, or by sharing of valency electrons in order to have octet, 8 electrons in their valency shell. Types of bonding. Strong bonds. Number 1. Ionic or electrovalent bond. Ionic bond is formed between the atoms by transfer of one or more valence electrons of one atom to another atom so as to complete their outermost octets and acquire stable nearest noble gas configuration. Definition. Ionic bond is the electrostatic force of attraction which holds the oppositively charged ions together. The compound formed is called ionic or electrovalent compound. Example, formation of sodium chloride. Sodium reacts with chlorine by transfer of the outermost electron of sodium to chlorine to form sodium chloride. sodium ion and chloride ion. Conditions for stable ionic bondings. Number 1. The ionization enthalpy of atom forming the cation should be low. Number 2. The electron gain enthalpy of atom forming the anion should be highly negative. Number 3. Lattice energy should be high. General properties of ionic compounds. Number 1. Physical states. Exist in form of crystalline solid, example sodium chloride. Number 2. Melting point and boiling point. High melting point and boiling point. Number 3. Solubility. Are soluble in water and other polar solvents but insoluble in non-polar solvents. Number 4. Electrical conductivity. They conduct electricity in solution or molten or fused state, but in solid state don't conduct electricity. Number 5. Ionic reactions. When dissolved in water, ionic compound splits up into opposite charged ions, hence ionic reaction can take place. Number 2. Covalent bonds or normal covalent bond is a bond formed by mutual sharing of electrons between the combining atoms of the same element or different elements. Hint: if two atoms share one electron pair, the bond formed is single covalent bond. Example: hydrogen chloride. If two atoms share two electron pairs, the bond formed is double covalent bond. Example: carbon dioxide. General properties of covalent compounds. Number 1. Physical states. Are liquids or gases at normal temperature. Number 2. They have low melting point and boiling point. Number 3. They are insoluble in water and other polar solvents, but they only dissolve in non-polar solvents. Number 4. They are bad conductors of heat and electricity. Number 5. They are less reactive. Number 3. Dative or coordinate bond is the bond formed by sharing of electrons where one atom or species or molecule bring a lone pair, a pair of electrons, and the other brings an empty orbital. Example: formation of ammonium ion. Ammonia plus hydrogen ion equals to ammonium ion. Ammonia plus hydrogen ion. The lone pair of ammonia combine with the empty orbital of the hydrogen ion to form ammonium ion. But the central atom that is attached to side atoms ligands become positive, and the dative bond is represented by an arrow. Metallic bonding is the force of attraction between valency electrons and the metal ions. The valency electrons are in delocalized form, which form sea of electron. As the number of electrons donated to the sea of electron increases, the strength of metallic bond also increases. Note: the smaller the cationic size, the stronger the metallic bond, and vice versa is true. Influences of metallic bonds. Hardness of metal. For example, aluminium has stronger metallic bond compared to sodium. That's why sodium is soft and can be cut with knife, while aluminium is hard and can be used to make cooking utensils. Electrical conductivity of metals. High tensile strength. High melting point and boiling point. Weak bonds. Hydrogen bonding is the attractive force which binds hydrogen atom of one molecule with the electronegative atom of another molecule. Cause of formation of hydrogen bond. When hydrogen bond is bonded to strongly electronegative element, the electron pair shared between the two atoms lies far away from the hydrogen atom. As the result of hydrogen become partially positive and the most electronegative atom becomes partially negative. The electrostatic force of attraction between the partially positive charged hydrogen atom and the partially negatively charged atom of neighboring molecule result into formation of hydrogen bond. Condition for hydrogen bonding. Higher electronegativity of atom bonded to hydrogen, small size of electronegative atom. Differences between hydrogen bonds and covalent bonds. Hydrogen bond involves dipole-dipole attractions, while covalent bonds involve sharing of electrons. Strength of hydrogen bond is very small, while strength of covalent bond is sufficiently high. Hydrogen bond is formed between hydrogen and highly electronegative atom of another molecule, while covalent bond is formed between the two electronegative atoms of the same element or different elements. Types of hydrogen bond. A. Intermolecular hydrogen bond is the hydrogen bond between two different molecules of the same or different substances. B. Intramolecular hydrogen bond is formed between hydrogen atom and highly electronegative atom present in the same molecule. Influences of hydrogen bond on physical properties. Association. Due to intermolecular hydrogen bonds, two or more molecules of compound exist as associated molecules. Higher melting point and boiling point. This is due to the fact Because of hydrogen bond, the electrostatic force of attraction in molecules become large. Larger energy is then required to separate these molecules before they boil. Solubility. Solubility of one substance in another is influenced by hydrogen bonding. Volatility. The compound involving hydrogen bonding between molecules have high boiling points, therefore they are less volatile as compared to the other corresponding members of their groups. Weak forces of attractions. Number 1. Dipole-dipole attractions. These forces occur when the partial positive charge part of a molecule interacts with the partially negative charge part of the neighboring molecules. Number 2. Random dispersion forces. These are the weakest of the intermolecular forces and exist between all types of molecules. Random force increase at the molecular weight increase. Covalent bond. Types of covalent bonds. Number 1. Non-polar covalent bond. Number 2. Polar covalent bond. Number 1. Non-polar covalent bond is the type of covalent bond formed between two atoms of the same element or between atoms having similar electronegativity. The shared electron will be located at the center. This results into non-polarity of the resulting compound. The electronegativity difference between the bonding atoms should be equal to 0. Number 2. Polar covalent bond is the type of covalent bond formed between two atoms having different electronegative values. The electron will lie near the most electronegative atom and far from the least electronegative atom. This will result into partial negative charge on the most electronegative atom and partial positive of least electronegative atom. Dipole moment is the product of the magnitude of the charge and the distance of separation between the charge. Dipole moment is a vector quantity represented by an arrow showing the direction from positive to negative end. Consider the molecule of hydrogen chloride. For non-polar compounds, there is no charge separation, hence the dipole moment is 0. Units of dipole moment is coulomb meter or Deb. Importance of dipole moment. Number 1. Distinction between polar and non-polar molecules. Number 2. Degree of polarity of molecules. The greater the dipole moment, the greater the polarity in such molecule. Number 3. Determination of shapes of molecules. Number 4. Determination of ionic character in a molecule. Number 5. Distinction between cis and trans isomers, which we'll study on the later videos on organic compounds. Polarization. When a cation is brought near the anion, the positive ion attracts the outermost electron of the negative ion. This results into distortion of electron cloud of the negative ion. Definition. Polarization is the distortion of electron clouds around the anions toward the cation. If polarization is more, larger will be covalent character of the bond. No polarization, the bond is mainly ionic. If degree of polarization is small, the bond will be with covalent character. The extent of polarization depends on both the ions. Number 1. The power of cation to distort or polarize the anion, polarizing power. Number 2. The susceptibility of the anion to get polarized by the cation. Fajan's rule. This rule summarizes the tendency of the cation to polarize the anion. Number 1. Smaller size of cation. The smaller the size of cation, the larger its polarizing power and vice versa. Number 2. Large size of anion. The larger the size of anion, the larger its polarizing power and vice versa. Number 3. Large charge on cation or anion. The larger the charge of the cation or anion, the greater its polarizing power. The orbital overlap. Valency bond theory. Only half-filled orbitals, different spin, overlap each other. Types of overlapping and nature of covalent bonds. Sigma bond, pi bond. Number 1. Sigma bond is formed by head-to-head overlapping. Axial overlap. S overlapping. Two half-filled s orbitals overlap. Sp overlapping. The half-filled s orbital of one atom and the half-filled p orbital of the other atom overlap. Pp overlapping. Two half-filled p orbitals overlap. Pi bond, sidewise overlap or lateral overlap. This type of covalent bond is formed by the sidewise overlap of the half-filled atomic orbital of bonding atoms. Differences between sigma bond and pi bond. Sigma bond is formed by head-to-head overlapping, can be between SS, SP or PP orbitals, while pi bond is formed by sidewise overlap of the two half-filled p orbitals. In sigma bond, overlapping takes place to a large extent and the bond formed is strong, while in pi bond, the overlapping occurs in lesser extent and the bond formed is weak. There can be free rotation of atoms around sigma bond, while free rotation of atoms around pi bond is not possible.